Question 12 was to do with the handling of interrupts at CPU level. Okay, so if we remember the fetch execute cycle, we fetch, decode and execute the current instruction, and then the last step we do before we move on, so we have to completely finish executing the instruction first. We then can check to see if there's any interrupts waiting. Okay, at that point what we can do is I've got the algorithm here. I'm not going to do any scribbling on this one, I'm just going to explain it. What we can do is then service the interrupt, but in order for us to come back and carry on what we were doing, we need to make sure we store the program counter, because the program counter, or the sequence control register, is referring to the next instruction to execute, and by the time we finish the fetch, decode, execute cycle, we should be pointing at the next instruction. So we'll need to save that, and the obvious place to save this is onto a stack. Okay, so as soon as we push the PC onto the stack, we can then load up the interrupt vector, which will have the address of the code that is going to process that interrupt. That can go off and do its job. Okay, and then when it finishes, it needs to execute a special instruction to say that it's returned from an interrupt, and that will tell the control unit to pull the PC back off the stack and then to start a new fetch execute cycle. What's important, as far as the CPU is concerned, it only cares about the program counter. Alright, it's up to the person who's written the interrupt handler to preserve any other registers. So if they know that they're going to destroy, let's say they were on a Motorola 68000 and they were going to destroy registers D0 to D4 and A3 to A6. The A registers are address registers, the D registers are data general accumulators, effectively. Okay, what they need to do is make sure that they pushed, because they don't know what the state of the CPU is, pushed all those values onto the stack before they did their tasks. Then when they finish doing their tasks, they need to pop them in the right order before they execute the return from interrupt command. Okay, and that's basically the general process of CPU handling requests. Now the example going about priorities of interrupts. So what do you do if you're doing an interrupt and another interrupt happens? If it's higher priority, you interrupt the interrupt. Okay, so you do this process again. You say, oh, sorry my old son, we're higher priority, so whatever you do, you'll have to wait until we've executed. Now most CPUs have levels of interrupt, and then they'll have a special level of interrupt called non-maskable, which means you can't block them. Okay, so they get the highest priority. But as far as the exam board concerned, if an interrupt happens and then a higher interrupt happens, then the higher interrupt is executed, and then we return to the lower level interrupt, and then we return to what we were doing before any of the interrupts happened at all. Okay, they tend to make that a wordy question. I think there's been a long question about that. So describe or explain. Not a pleasant question really, because you can ramble on for that one. Okay.